Thank you for joining today. We will begin shortly. Give it another 60 seconds or so. All right, well, top of the hour, so we're going to go ahead and launch in. Thank you for joining us the day before a long weekend. We know that there's lots that you could be doing during this time, and we appreciate you taking the time to be with us, associates, and also Amazon Web Services. So on that note, welcome to today's webinar, Modernizing Your Oracle Applications with AWS Data Lakes and Amazon Redshift, as we continue our series with AWS, A Modern BI Journey. I'm Audrey Eloquent, AWS Alliance Manager at Apps Associates, and I'm fortunate to be joined today by Sudhir Gupta, Senior Partner Solutions Architect at Amazon Web Services, as well as Srinivas Pathareddy, VP of Analytics, and Praveen Sharavu, Director of Analytics at Apps Associates. Thank you all for joining us today. My heartfelt thanks to to our team and to those who have tuned in. Like last week, I'd like to walk through a few house rules. This session is being recorded. Your lines are on mute, although questions are encouraged. We will cover those at the end, so feel free to submit them in the chat box on the side. Today's session will focus on how to unlock your Oracle ERP data to empower your business users. Praveen will first delineate between the traditional approach to on-premise data warehousing and outline a more modern approach leveraging data lakes. Then Sudhir will guide us through data lake formation, leveraging AWS's tools such as Redshift. And lastly, the Apps Associates team together will showcase that data warehouse migration is feasible in terms of the process, and that it is greatly supported by AWS, while exhibiting specific examples where we've worked with customers to help them to do more with their Oracle data by leveraging a modern data warehouse solution. We'll end today's webinar with Q&As and closing remarks. And so on that note, I'd like to go ahead and kick things off with Srinivas. Over to you, Srinivas.
Thanks, Audrey. So I'm going to introduce the agenda today. The primary purpose of the agenda, or what we're trying to cover today, is going to be introducing Oracle application customers to Data Lake and to Amazon Redshift. So, and then there are a lot of customers that are still in the traditional warehousing space, and we want to kind of talk to them and guide them in this process. So as part of this, we want to kind of talk about the processes and the approach that we have followed in traditional warehouses. These have been on-premise warehouses. We'll talk about how do we switch from the traditional approach to a modern approach with the data lake and a modern approach to using AWS data analytics. And then we'll kind of take the next step of how do we build that using AWS Lake Formation, followed by, if you have an existing Oracle database or data warehouse, how do you enable that and migrate that to Redshift? And then we will kind of conclude with a use case that is going to show about how do we get data and populate the data lake, that is building the data lake. And we'll talk about best practices with respect to design and execution best practices in the data lake and Redshift. Now, quick introduction to Apps Associates. Apps Associates was founded in 2002 by ex-Oracle consultants in the Boston area. And right now we have employees and locations all across the world. So we have offices in US, Europe, and India. We have around 300 active customers, employees across the locations, both US, Europe, and in India. And we have a broad range of specializations, starting from business application implementations, focusing around Oracle and Salesforce business application implementations, followed by analytics, a wide range of services and analytics integration between different business applications. cloud services and application managed services. So these are services which help making sure that customers are able to manage their existing applications and infrastructures seamlessly on a month-to-month basis. And then the reason we are talking about this very focused webinar on Oracle and Oracle technology, using Oracle data, application data, and how do we use that data and how do we into AWS data analytics. So the reason we're talking about Oracle data and Oracle applications is because we have a lot of background with Oracle applications. We've been implementing Oracle applications for a number of years. And this includes ERP, supply chain, HCM, EPM, and both implementation and managed services. So based on the experience that we have built and the knowledge that we have gained in the business process and the data, it kind of makes it much more suitable, much more easier, efficient for us to use this data and for both analytics and insights. And taking that, we will take the next step of how we use that data and use that information to build a data lake in AWS and also use Redshift in the process. So Praveen is going to guide us through the next steps of walking through the traditional approach and the modern approach, and he will go through the detailed steps in this process.
Thanks, Shivas. So before jumping into the traditional traditional approach, I want to give an understanding about what a data warehouse is, right? So a data warehouse is basically a process for collecting and managing data from a variety of sources and provide meaningful business insights to any organization, right? So currently, in this process, what we're doing is you have disparate systems, basically ERP cloud and Excel files or your on-premise system. And we typically load that data into a warehouse kind of thing, which usually is built on star schema kind of a model, where the data gets segregated into facts and dimensions kind of objects. And then once the data is available, you tend to report using any of the analytical tools, right? One of the key aspects of going through this approach is that you go with loading the data row by row into your traditional data warehouse because of the OLTP or the data warehousing modeling that is done behind the scenes, right? And when you go with a row by row approach, indexing and hash joins, they are pretty much favored. But the caveat that you get out of that is that you don't get, if you have huge volumes of data, you don't get the kind of performance that you look for, right? Usually the star schemas has, because of the modeling that you do, you normalize the data and you are actually not duplicating the data sets. So if you want to look at what are my sales by specific customers, you have to actually join two or more tables and try to retrieve the data. So when you do that, the more the data volume that you have, you actually end up taking a performance hit, right? So that's what we usually see from a traditional data warehousing. So that being said, we want to understand what are the new approaches, right? So if you really look at it from a warehousing standpoint, these are some of the common pain points that we see. The first aspect that you see is scalability. So as your volume grows, it's hard to scale from the existing infrastructure that you have. You have to, because there is a upfront cost of procuring the necessary hardware and stuff, right? So you're actually going away from that. The second aspect is the infrastructure. Basically, maintenance of the entire system, whether it is data warehouse, whether it is the application or the front-end application or the ETL process or any of the tool set that you utilize, right? You have to keep on maintaining those things. And it's an ongoing maintenance that you have to go through. And finally, the performance is a bottleneck, as we have seen with huge customers where initially the traditional data warehousing works with less volume of data, but as automations grows and they keep on adding new source systems, new applications, then you tend to see that it's being overburdened with the current infrastructure that you have. So, so what we usually look at it is there are two major aspects that's being compared from a data warehouse and a data lake strategy, right? So before going into the comparison standpoint, I want to bring what a data lake means, right? So data lake is basically a landing zone of disparate sources of data. Commonly, like in your data warehousing environment, you just look at structured data because of the source systems that you have, whether it's Excel sheet or applications. Whereas from a data lake standpoint, you don't concern about what kind of data you're actually fetching. You just store whether it's video files, image files, structured, unstructured, semi-structured, any kind of format. You're trying to store that into a specific place, and that you call it as data lake. And when that picture comes into picture, that picture comes into view, the common question that comes in is, okay, whether to use data warehouse or data lake, right, from an organization as they move towards a cloud strategy. So before jumping in, we would first compare what are the differences or comparison points, and then dwell into what it fits from an organization standpoint. So if you really look at from a data warehouse, it's a top-down approach. So what it means is before building any data warehouse, you have to go through understanding what is the business requirement, what is the strategy of an organization, how do you take up what business needs are being met by fulfilling this, right? You have to think through these aspects and then build your data warehouse. Whereas from a data lake standpoint, all you are thinking is data, what data is important, what data adds value in the future. So you're actually understanding, okay, these are all the different source systems which you want to go, and you go towards that. And from a processing and from a price standpoint, each has its own points. On the data warehousing side, you are really looking at how much data the business really looks for. So you kind of take some shots on, okay, do I really want 3 years data, 2 years data, kind of an approach because of the performance bottlenecks or things of that you have in the traditional approach. Whereas from a data lake standpoint, you don't really look at those aspects because it's pure storage cost that you look at. You don't look at the compute aspect. So you keep on adding more data as it comes in, and storage being cheaper these days, that's not really anything on that. And then when it comes to the how the data is secured from both the environments, one of the data set is based on the business needs. So you can have financial data, supply chain data, or human resources data in a data warehouse, but you give access to each of the data sets based on the kind of business that they want access and look at it. Whereas from a data lake standpoint, it's more about data centric. So you really look at, okay, whether the users really understand their data pretty well, and based on that, you tend to give access, right? So these are common comparisons that you look at from any organizations. But what we suggest is that it doesn't mean that if an organization goes towards a data lake strategy, they have to exclude data warehouse. They go hand in hand. It's just that data lake fulfills some of the needs where going forward you're going towards a machine learning or AI strategy or IoT kind of thing. Data lake fulfills that needs, whereas for your operational regular analytical processing, you still need a data warehouse kind of aspect. So here what we are trying to look at is we're trying to understand from a traditional approach we have seen earlier how our process looks at your loading, right? Whereas here we're trying to look at from a modern approach how you load this data into your warehouse or data lake strategy. So what you see on the left-hand side are all the different source systems. So you name it, Oracle application, PBCS, master data management, or any IoT data, or anything else, right? So the first aspect that we look at is when you're going towards the modern approach, you're not doing any, you're extracting the data as raw as possible. So that's where you see when we say raw, it means that it matches to the exact replication of your source system. However, in whatever fashion your source system is managed, the raw layer basically replicates that. And once the data is available in your raw layer, then we are just trying to, from an analysis standpoint, if users wants to see, we are utilizing in this approach, we are trying to load that into a raw schema of a Redshift layer. And then after that, we are trying to curate that data and store it into a curate schema. So what we're doing between a raw and a curate is because the data comes from multiple source systems, there are obviously times where some data types doesn't match, or some maybe date values doesn't match, things of that nature could be there. So you're just trying to cleanse those aspects, make sure that everything is in one structured format, kind of from an analytical purpose. So you're just trying to adjust those aspects and curate them, and then at the end store that again into a curated bucket for future references from a data lake strategy. Once the data is available from a curated schema, you're then going into the transform schema, and that's where you are really looking at from a business aspect. What is the business needs from different source systems or different application standpoint. So this is a schema which would be connected to your analytics systems, mainly Tableau, QuickSight, Power BI, etc. So you're utilizing this transform schema where you are actually creating kind of data marts or a subset of data which can be utilized, and you are also making sure that you are transforming and storing into the data bucket. So in this entire flow, one of the key aspects that you see is there are different things that are being considered. The first aspect is as you're extracting the data into the raw bucket, one of the key thing is here there is no computational. You're just working about a storage aspect, right? All the S3 buckets are just a storage aspect. You're not really looking at a computational power. And all the data sets is compressed. You're looking for heavy compression that is being happening as you load, whether it's in the buckets, S3 buckets, or whether it's in the Redshift, you utilize some of those capabilities. And the data loading is faster because you're not doing any transformations or doing any kind of processing on the source systems. Rather, you're utilizing the warehouse or the data lake strategy over here. There is a different approach.
Praveen,
yeah.
It's Carla. I'm sorry to interrupt, but we do have one real-time question come in.
Sure.
What does schema on the right versus schema on read mean? Can you dive in a bit deeper, please?
Schema on the right and schema on the read. Can you just repeat
on
that?
write and on read? Yep.
Oh, schema on write and schema on read. Okay, so basically,
yeah.
So one of the so the main aspect is let's say on a data warehouse, right? You have a specific table where you are actually loading. You already have data, right? And you're using your analytical tools to actually look at that data set. If it is a schema on write, it means that you cannot update, or as you're updating the data into a specific table, then it actually, whatever the result set that the business sees, there is obviously a disconnect between that. So that's what a schema on write means. Whereas a schema on read means even if there are some processing that happens as you're loading the data, there is whatever the business sees, they see actual numbers and details regarding that. Is that
Thank you.
Okay, thanks. So there is a different approach which we obviously see is so earlier what we showed is one of the approach. This is another approach where you're not really loading the data into Redshift, but you're loading as part of the process. You're going through raw schema, curated raw bucket, curated bucket, and transform bucket. But you're actually managing that internally within the S3 buckets, and all you're doing is you're just managing the transform data into the transform Redshift schema, and that's what you're utilizing. So the advantage of this approach is basically you're utilizing machine learning or some of the other tools of AWS like SageMaker, Athena, EMR, or Redshift Spectrum. You can utilize any of the tools which can directly read through the S3 buckets and try to do analysis out of it. So each of those has different pros and cons. So basically, that's what we are presenting. Sudhir will be taking over from here. Sudhir, you want to look at that? Thanks.
Thanks, Praveen, and hello, everyone. Now I will talk about the AWS Lake Formation and the Amazon Redshift. So let's start with the process involved to build a data lake when you perform a manual steps. So, it starts from the setting up the storage. So means before you do anything, first you need to create an, Amazon S3 bucket if you are creating a data lake in AWS environment. And if you are using the on-premises environment, you build, you procure the hardware, set up the disk of arrays, and that can hold the data in your data lake. And the second step is the moving the data. So basically you connect to the various source systems, which is on the on-premises or in the cloud or in the IoT systems, and move the data from these various source systems into the data lake which you have created. So customers are normally using, the various file transfer utilities or the ETL tools like the AWS Glue. The third steps is cleaning and preparing the data sets. So basically, whenever you collect the data in raw format, which is really not optimized for your analytics and the machine learning. So for that purpose, the data engineers who are managing it, they do the data cleansing, they perform the data duplication, and then they transform these records in the manner it is more performant for the auditing, the analytics they want to run in the data lake. Then the fourth step is setting up the securities and the compliance requirements. So definitely, it depends, varies from customer to customers, but there will be some security requirements which you need to achieve it, like encrypting the data at rest. If whatever the data you have stored in Amazon S3 or any other data lake, first you need to encrypt it. And another requirement can be setting up the table level, column level, or the row level security and audit those activities. Who are accessing those sensitive data, and you need to definitely monitor it so that you can flag if something is going wrong. And at the end, definitely, once the data is cataloged and make it available to the analyst, your data analyst can run the various analytics and machine learning to gain the insight from the collected data. So with this manual process definitely requires so many steps, and in order to build a fully production data lake, it takes a month to implement the solutions. And what we are hearing from tens of thousands of the customer, that they want to make the data lake process, data lake building process, to be easier and the faster than as we today, because the current process, it's not just the take more time, it's also the error prone. Then you need to make sure so many other things in order to make sure things are doing it correctly and the integrity is maintained. The good thing is we have a service which is called the AWS Lake Formation, which helps the customer to set up a secure data lake in few days. And it provides a unified GUI to build, a configure, and monitor your data lake in the AWS. You can basically simply, just define the source connections, and then Lake Formation service will automatically crawl these data sources and move the data into the Amazon S3 data lake. And the Lake Formation also convert these data into the proper partitioning, and even it converts a file format like the Apache Aparque or ORC, which is really quite efficient for the modern analytics. And it also performs the data duplication task and to find the matching records to increase the data quality. The Lake Formation can also be used to define the security governance and auditing policies from one place, rather than when you are not using the Lake Formation, you might have the different, engines, different processes to, move the data around from one place to another place, from the until the end users. So one option is define the security at all the different level. So whatever the services you are using to access the data from your data lake and data warehouse, do it manually. Or alternatively, you can find the security governance auditing from one common place, which is the Lake Formation console. Plus, definitely, you can do the entire set of the auditing. All the activities which is happening into your data sets. So this is a really cool service, I believe, when you are in process of making the data lake. And another advantage of having the data lake formation is there is no additional charges. You pay only for underlying services you used. So for example, you use the Glue ETL to move, do the data duplications, or maybe the converting the file format. Yes, then the underlying utilizations, yes, you need to pay. If you are using the Amazon Redshift to access the data, from the data which is part of the data lake, yes, then you pay for whatever the cost is associated to the Amazon Redshift or Redshift Spectrum. So it meaning that you don't pay anything for lake formation, but at the end you pay for something which whatever the underlying services you are using it. So as the Praveen said at the beginning, one of the most common challenge with legacy data architecture is that difficult to extract the data, extract the value from the collected data. And to realize the value of the data, customers are increasingly moving towards the data lake architecture. And Amazon Redshift is a unique solution that offers a true data lake house approach. So when I say the data lake house approach, it means that you have the full flexibility to store the highly structured and frequently accessed data in the Amazon Redshift data warehouse, and keep the exabyte of the unstructured or semi-structured data in Amazon S3 data lake. So that when you execute the queries, you can have the access to your data warehouse as well as the data lake from one place. There is no need to load the entire data sets which is sitting in the data lake into your data warehouse. So this offers not just scalability, it also helps you to keep your data warehouse size lean to save the cost. There are some other benefits of using the Amazon Redshift. For example, the first benefit is the data lake and AWS integration with the AWS services. So we have a service feature which is called the Redshift Spectrum, which gives you ability to query the data, whatever the data which is stored in the open file format in Amazon S3 data lake. And then we also offer a feature called the federated query, which gives you the access to query the data which is stored in your transactional databases like Amazon Aurora Postgres or the RDS Postgres SQL databases. So basically you have the full access to your source systems and the data lake and from the data warehouse using the single endpoint of the Amazon Redshift. Redshift is also integrated with some other services like the Lake Formation. And in the previous diagram you have shown, you can leverage the AWS Lake Formation, and you can you can use the Redshift Spectrum and Amazon Redshift to run queries against the data lake. And for the monitoring, it is integrated with the CloudWatch logs. If you want to move the data from one databases to another database, yes, you can use a DMS or SCT. And all these services are well integrated with the Amazon Redshift. Amazon Redshift is engineered for performance. What we have seen, the Redshift offers at least 3 times faster performance than any other cloud data warehouse. And when you compare with the on-premises, Redshift gives the performance up to 10 times. It depends what kind of source system, but definitely this is a faster than any other cloud data warehouse or the legacy data warehouses. Amazon Redshift is also very cost effective. You can create a very basic one smallest Redshift cluster by paying just 25 cents per hour, and you can scale up to 1 terabyte just $500 per terabyte per year using the new RA3 node types. And in additions to this cost, you can also have an options to do the reserved instance. And when you purchase a reserved instance for your Redshift compute nodes, then customer can save up to the 75% up to 75% cost from the if you compare with the on-demand pricing. The Redshift is also highly scalable with the concurrency scaling. Now it can support virtually unlimited concurrent sessions. You can process it with Amazon Redshift, and also when the storage wise, right, you can scale it from few GB to few petabyte with just few clicks. Amazon Redshift, another benefit people get it is like the security. So with the Redshift, you get all the security features at no cost. However, when you look at any traditional data warehouse systems or any other cloud data warehouse systems, you always pay extra to enable the security features. Amazon Redshift provides all kinds of security features like the encryption at transit, encryption at rest, and network isolations, and it is also certified for various certifications like SOC 123, ISP CI DSS level 1, HIPAA, FedRAMP, and some more. Redshift, the last thing is easy to manage, and it is a fully managed cloud data warehouse. So, and most of the things are automated. Like you don't need to worry about the patching, hardware monitoring, failure, recovery, backups. Everything is taken care by itself. Even most of the maintenance tasks, like the vacuum, gathering the statistics, all these things are also automated. So it's a really, very minimum thing which we are expecting you to do it to get, to manage your cluster. Now let's take a look of some of the key aspects when you perform a data warehouse migration. So these are the typical 5 phases involved for the data warehouse migration. It is start from the evaluations, and basically you in these steps you perform the comparison. I mean the features comparison between your source systems as from the Redshift, whether these features are really compatible and you are able to achieve it with the Amazon Redshift or not. The second steps will be performing the quick POC to demonstrate whether the functionality features are working as expected and you are able to get the performance what you are planning or not. And then third is build a migration plan. I mean, definitely, because it requires so many other things. It's not just moving the data. You also need to make sure, you have built the proper ETL pipelines, and the ETL pipeline is, pointing to the new destination. So definitely you need to build a proper data, design, you need to build the design migration plan. And then the next step is build, perform the data migrations, perform the data integrations, and the validation test. And at the end, the obvious steps is, setting up the operational perspective, how you are going to maintain the new data warehouse and look for the possible optimizations. Because when you are moving from legacy systems to the, modern data warehouse, it looks like, initially people prefer to perform as is migrations, but definitely there are so many extra capabilities which the Amazon Redshift or the new data warehouse provides. So, the next step is, look for what kind of things you can optimize based upon the capabilities of the new modern data warehouse. In AWS ecosystem is a broad and deep, and it includes, the tools and technologies that it makes it easy to migrate a data in the AWS cloud. So some of the tools and utilities available in in the AWS cloud listed here, but the scope is not limited to that. There are many more services which helps you to move the data from various sources into the Amazon Redshift or any other databases in AWS cloud. Plus, definitely, with you also have, we as AWS solutions architect, we are also helping to the customer and the partners throughout the journey. Starting from the planning to the real executions, we are always available to help you guys. So let's give me some background about a few services which you can use for the data or data warehouse migrations. So easiest thing is, the first most common thing which you can think of to migrate a data or load the data in AWS is S3 API call. So by just making, some API calls, you can load the data into the AWS. And even we have a service, maybe a feature called AWS S3 transfer accelerations, which can help you, to improve the performance of data ingestion by up to 300%. So basically, what happens when you enable the S3 transfer accelerations, the communication happens from edge locations to the S3 bucket inside AWS network. So you get the consistent fast performance. And we have the snowball. When you have the really large data sets and you want to migrate into the AWS environment, we highly recommend use one of the snowball devices. So this is a physical appliance. We ship it to the client side, and then you can offload the data into the secure manner into the snowball devices, and then we ship it and make it available in Amazon S3. So that because what happens, no matter what kind of network bandwidth you have, if you have huge data sets like the terabytes or petabytes of data, it might take some few days to few months to upload this data. But with these snowball devices, you can convert and migrate these huge data sets into the AWS environment in a couple of days. So it really accelerates the performance, the data movement speed to the AWS. So we also provide several ISV connectors, which you can use to migrate the data from various legacy databases or data warehouse systems into the AWS environment. And if you have the real-time data, you can use our Amazon Kinesis services to migrate the data, from various, the real-time devices, IoT devices into the AWS environment. And the two most common tools which people are using a lot to migrate a database or data warehouse are called the AWS schema conversion tool and the AWS database migration service. So as AWS SCT is a tool which helps you to perform the heterogeneous database migrations to one of the supported target database. And it's so when it converts a schema, it includes all the objects like the tables, views, stored procedures, functions. It will convert to the compatible into the file in the format which is compatible to the target database. So suppose if you are migrating your Oracle data warehouse into Amazon Redshift, and if you use SCT, all the stored procedures, functions, procedures, which tables, views, which you have created in the Oracle data warehouse, you can easily migrate, convert and migrate into the Amazon Redshift, by using the AWS SCT tool. And SCT tool is not just used to migrate the schema, it can also be used to migrate the data. So you can use the AWS SCT data extractor agent to migrate, the range of data, the data from various data warehouse, like the Oracle, SQL Server, Teradata, Netezza, and all to Amazon Redshift. The second service, which is quite famous to perform a database migration, is known as the AWS Database Migration Service. So once you have converted, the schema using the SCP, the next step can be, migrate the data using the AWS DMS. So AWS DMS also provides a homogeneous or heterogeneous data migrations from one place to another place. And the good thing is, it comes, you don't need to pay for first 6 months if one of the target is, if the target database is Aurora, Redshift, or DynamoDB, or the DocumentDB. Now, go to the next slides. Okay. Now let's take a look of the various phases. The process when you perform a data warehouse migrations. So as I said at the beginning, the first step is always the perform the the schema conversion. Whatever the DDL or DMLs you have created, you need to convert it. So you can use either the AWS SCP, or you can also use any third-party tools and scripts to convert this schema from commercial data warehouse like Oracle to Amazon Redshift. Then the next step is migrate the data. Once the schema is converted, you will now you have to migrate the data. So you can leverage either the AWS DMS or AWS SCT data extractor agent to move the data, or you can also leverage their native tools, to migrate the data from your source systems to Amazon Redshift. So for example, if you are using the Oracle, you might prefer, one possibility is you may configure your backup of Oracle databases directly writing to the Amazon S3. And these databases, then from the S3 data, you can restore it in the AWS environment. I'm just giving an example. Like for Teradata, you can also use a TPT tool to write the data directly into the Amazon S3. And once the data is available in Amazon S3, you can run the copy commands to load the data in Amazon Redshift. Or if you want to be the AWS native tools, feel free to use a DMS and the AWS SCP to migrate the data from source systems to the Amazon Redshift. And when the data set is large, you can alternate approaches. You can use the DMS SCT to write the data in Snowball, and from Snowball, we will make it available in Amazon S3, and from there, you can load the data to Amazon Redshift. The third step is, so okay, when you perform the initial load, right? So now you need to perform the delta and incremental catch-up. So most common pattern to perform a delta, I have seen when you are using the DMS, people prefer DMS to perform the CDC, but if it is not DMS, then people are normally, I have seen, especially in the data warehouse environment, people are using their own ETL tool or their own custom code to cover the delta from your source system to Amazon Redshift. And once the data is loaded, then you need to establish the migrations factory. It includes the design, build, integrate, validation. And when the validation is done successfully, you plan for the cutover, and that's it. And if you find some issues and anything, you again go to the phase of design, build, and integrate. And at the end, you will have the fully database and data warehouse migrated to Amazon Redshift. Now, I would like to pass over to the Praveen to continue from here. Hey, Praveen, now it's over to you.
Yeah, thank you, Steve. Thanks. So what we're looking at is a specific case study that we have done. So we have a customer who is in the retail industry, and they generate close to 40 to 50 million transactions per month of sales orders, right? Currently they use a traditional on-premise data warehouse, and what they have seen is, especially from a sales order standpoint or customer reporting standpoint, they see a lot of bottlenecks because of the huge volume that gets generated. Also during the month-end closing, if they are looking at their general ledger or any sub-ledger accounting to do any reconciliation, it really takes them a lot of effort to really look at it because of the performance stuff that they go across, right? So what we have suggested on this case is the customer has picked AWS Redshift as their cloud data warehouse. And as I've explained in my earlier modern architecture, right, or modern approach, we have extracted all of this data into S3 as a raw layer first, and then loaded into Redshift. And once the data is available in Redshift, when they are doing their analysis of sales by customer or sales by region, or they're looking at GL analysis, account analysis, or anything of that, they get data within seconds, purely because of the columnar database architecture that is underneath the Redshift, and the kind of analysis they look at, right? So definitely with this, we have seen a huge improvement from a customer standpoint, and that has also enabled them self-service, specifically using the analytical tools like Tableau. Now the customers are looking at building their own analysis, because now they can leverage huge volumes of data, and they can do all their trend analysis, rolling 12 months, everything of that nature based on the data that they have in the Redshift. And it was highly impractical for them to do that in their earlier application. And going into the specific details of the application, right? So what they have is I think on the international side, they have Oracle EBS. That's what they use. And for the US entity, they have the cloud ERP system. And this is an example of a journal reporting where they were doing some kind of reconciliation between their journals and accounts payables and journals and inventory kind of data set. And we're just showing a glimpse of what we went through and how we build that, right? So you can see that what we have done over here is, because there are multiple source systems, we first identified what kind of objects we have to extract. So from a cloud standpoint, we're extracting the different objects that are mentioned over there. And from the on-premise ERP application, we have identified similar data sets that are available in the respective tables or views. Once the data is available, we are, as I mentioned earlier in my architecture, we're just extracting as raw as possible. So we're not doing any transformations, loading or grouping multiple tables, nothing of that nature. We are just extracting as it is into the raw bucket, which is in the S3 schema or your data lake. So once that data is available in the raw bucket, then we are just transposing that into the Redshift. We are just loading that data into the Redshift. And Redshift also, you have the raw schema. And the purpose of this, the reason we are doing this is their IT team is also doing some analysis in the raw layer. So in case there is some issues when they are reporting from an end reporting standpoint, if they want to do analysis or backtrack, they easily can figure out. And that's the reason we are loading, in this case, the raw data also into the Redshift. Once from there, we are actually transforming into the business case. So in this case, because they're looking at their journal data set, so we created a journal data mart or a data set over here. And then that's what we are using for reporting purpose. So similar activity we are doing for their balances data set, for their sales order data set, things of that. And when we do want to do analysis, we are just extracting report based off these multiple data sets, and they're able to fulfill their needs. One of the key things that you're also seeing, similar to what I've already explained, is the key purpose of having different schemas is purely to analyze and understand, okay, if there is an issue from a data standpoint, is that really coming from the source? Which source is this coming from? And what kind of changes or what kind of data governance strategy they have to put together, right? So that's the reason we have separated it out. When we are storing the data into Redshift, we have segregated the raw schema as well as transform schema. Some of the best practices which we followed as part of the execution is the first key aspect is sort keys, right? So in this case, the use case is related to the GL balances. So when we are defining GL balances, because the balances are based on a period, we have partition or we are sorted based on the period. So the moment the data is fetched and loaded into the Redshift table, it automatically sorts. And if you want to really do a okay, show me my balance as of 1st January to end of January, or maybe for a specific period, it is much quicker. So we have utilized that approach on that. From a sales order standpoint, this particular customer is more concerned about how many orders are being created. There's more analysis that are done based on the order date. So we have actually, as we are loading the data into the Redshift table, we made sure that we are creating a sort key on that, so that the data is already pre-sorted, and when you do any analysis, it can easily fetch that. The second key aspect is the distribution keys. So from a GL balances, we want to make sure that the customer is using 4-node architecture. So we just want to make sure that the data is distributed evenly across all the nodes. So we don't want to make sure that only one node is basically heavy loaded. So when you do that, when you're doing any analysis by account or by period, it really doesn't go well. So that's the reason we made sure that we have distributed, and the distribution is based on, again, the period with which we have already sorted. And we have also added account because they do a lot of analysis at the account level. And as I mentioned, on the sales side itself, just they create close to 40-50 million transactions per month. And on the GL side, overall, they have close to, I think, 1 billion transactions till now created. So there's a huge data volume that is being maintained. So we just want to make sure that proper performance comes out of the result. Then for sales orders, again, because they created different types of order types for their business, what kind of source the data enters, they've segregated differently. In this case, because it's a retail kind of, so they've segregated based on some product categories. They created different order types, and they do a lot of analysis on how each category is being growing and over the years, right? So that's the reason we made sure that we are also segregating based on the order type. So some of the key things which we have also done just to keep from a performance aspect, right? we made sure that in the entire analysis, we are not doing any select star kind of analysis. So the reason for that is, as I mentioned earlier, Redshift is a columnar database, and not only Redshift, most of the cloud databases or columnar database. And when you do columnar database, you get peak performance when you are saying show my sales by a specific customer, region, period, things of that nature, rather than if you say select star, right, and you're fetching like 100 columns, right, and you're just fetching for all the data sets, right? So you really don't get the best out of that. So that's where for most of that, because the need is analytical purpose, we have made sure that we are not doing any operational or reporting where we are just fetching 50 columns, 100 columns, things of that nature. The second key aspect is not to set any compression, and especially sort keys for the first column, we need to exclude that. So the reason for that is basically, as we are loading the data, we make sure that we want to utilize as much as data as possible from a database standpoint. So we compress that data and we store it. So we don't want to uncompress and compress those aspects. So sort key, we exclude that. The first column of the sort key, we exclude from that. And the column compression has to be set at the time of table creation. So for this, what we have done is, as we are loading the data, we've initially created a temporary table just to understand, load 1 month data, understand what kind of data sets, what kind of attributes we are loading. And once the data is available in a temp table, we have analyzed, we have utilized inbuilt Redshift queries to understand what kind of column encoding has to happen. And based on that, when we define the final fact or the data mart that I've said earlier, when we created that, we made sure that these compression or encoding standards are effective against each column. So that's how we have approached that one. And the last one is the workload management policies. So this one, based on the need and the type of workload that you do. So what we have done is we have created different workload policies. Specifically, we want to segregate all the ETLs to utilize one kind of workload policy versus when you're querying the database, right? We want to segregate that. So we made sure that we created different policies which doesn't get cross-coupled. So we want to make sure that we have deviated that. So that's the reason we went with the different WLM policies. Srinivas, over to you.
Yeah, I would like Audrey to kind of talk about the next steps.
Happy to, guys. All right, so in terms of the next steps, it's been, we're partially through the series, and we do want to recap at times what we've learned, and then also to chart out where we're going. So from a next step perspective, part of it is we've been doing it for a while. So one, we would encourage you to hear from other customers, whether that's in the form of a case study, references, or other examples of what we've seen. That's typically where we find the most positive interaction between our customer base, and finding use cases that are very specifically tailored by industry, by vertical. Two, again, leveraging us and the team. You met Praveen, you met Madhu up until this point, and Srinivas along the way. So those are the first two steps. And then three, the experimentation process. One of the best things that we can do is just to dive in and to leverage subsets of a tool such as Redshift to start to dig in, while we utilize specific to Oracle on the ERP data to better understand how that plays out and how we can draw further insight based on the data itself. And so with that in mind, I might have just touched something I shouldn't have, Praveen, but I actually wanted to go ahead and conclude for now and enter into more of a Q&A stage. So thank you, Sudhir, Srinivas, Praveen, for your time and for helping us to better understand the variances in data warehousing and how we can specifically leverage it to unlock further insight with our Oracle ERP data. So with that in mind, wanted to go ahead and launch into a couple questions. We did have a few that hit the chat window. So number one, I'll leave this as an open-ended question, so whoever would like to take it. Do we need a data warehouse along with a data lake?
So yeah, I can take that, Audrey. So as I've explained earlier, each data lake fulfills a set of specific business needs, and data warehouse does a specific. So most of the organizations that we see is you would end up utilizing both of them, because data lake is more for the use cases are more catered towards machine learning, AI process. So when you're going towards that direction, obviously the end result of that, once you identify your data sets, then you want to automate that kind of a process into your regular activity. Ideally what you'll do is, once you identify that, you would push that into your data warehouse, and that's where you do, you make sure that. So to answer yes, I think you would end up utilizing both data warehouse as well as data lake in some extent.
And Praveen, I just want to add a little bit more things
Sure.
on this aspect, especially when you are using the data lake. Data lakes gives an ability, to use the multiple analytics engine, like maybe you can use a SageMaker or Athena or Redshift Spectrum, or maybe the QuickSight, So it it offers the ability to get the insight of your data, which you have collected from various sources using the multiple engines, not limited to a specific data warehouse. Yeah, so data warehouse will be one of the consumer, but it is not going to be, the only consumer. So, and the data is keep growing, and it's very difficult to fit, maybe the exabyte of the data in single data warehouse. So definitely, as a cost-effective solutions, it makes sense to have set up the data lake, and the hot data which you are, where the business analysts are running the query very often or have some aggregated data, keep it in the data warehouse, and everything else just leave it in the data lake, but make it available for the analytics.
Thanks, Udit.
Excellent. All right, guys, one more, and then I'll go ahead and conclude for us. But thank you again for the time. So last question, how would extraction of data from Oracle application be different compared to traditional warehouse implementations?
Sure, I can take that already. So again, as I mentioned earlier, so in the traditional data warehousing, the data was, in most cases, the data was not extracted in a raw format. There was some kind of manipulation or cross joining multiple tables and loading that data. Again, the key process was making sure you're leveraging star schema kind of modeling. So you're actually normalizing the data, right? Whereas when you look at the new process, you're not doing that. You're trying to denormalize as much as possible. So you're just loading the data as raw as possible, and then you're utilizing different tool set. So the burden is not on the source system earlier. If you're just extracting the raw data, select star, and extracting the table as is into the warehouse, and then on top of that, you're doing the transformations and loading. So the key difference I would say is, earlier we used to do extract, transform, load kind of a process, whereas now it is more catered towards extract. You're extracting raw as possible, you're loading that data, and then you're transforming your data within the warehouse.
Okay. Srinivas, Sudhir, anything else to add to that?
No, that's good. Thanks, Praveen. That was a good explanation.
Excellent. Okay. Well, all thank you again for the time. So just to preface next week, our webinar will be, it's titled Finance Visualized, Driving Business Insight with Redshift and Oracle. And so as more of an FYI, this session takes on a business-focused lens, specializing in finance, and it will involve key examples. And so for the next 3 series, starting with finance and continuing on with supply chain and HR, these sessions will be a bit shorter. So averaging more of 30 to 40 minutes, but they will pack a punch. So again, enjoy the weekend. Everyone stay safe. We thank you for joining us to the greater team from an AWS and Associates perspective, but look forward to having you next week and continuing on the series. All right, stay well. Thanks, guys.